Hello and welcome back to our series on modeling a data architecture. In our last episode, we brought in our building blocks from the solution architect to start our design process. So what we're going to be talking about today is moving into detailed design from high-level design and validating our architecture. So let's get started. Machine learning and AI systems are data-driven and involve complex workflows, data processing, model training, evaluations, and deployment. So since Sparks is data-driven, this makes it best for case platform and ML AI system architecture. In this episode, we're going to focus on data flows and transformation, model architecture and components, interactions between those components and other systems, and scalability and deployment considerations when we're doing our design. Using UML for machine learning and AI projects can enhance communication, design clarity, and system organization. In this session, we're going to talk about the best ways to use UML for machine learning AI, and you'll hear me call it ML AI, tailored to their unique workflows and components. We will focus on 4 different types of UML diagrams, starting with use case, which helps us capture interactions, class diagrams, which model static structures, activity diagrams that support dynamic workflows, and sequence diagrams for interactions over time. We're going to start with use cases. And what we've been talking about in this channel, and I'll try to include a link below, is we have a specific template that we use for driving our use cases. So we reuse this template across any of our use case elements. And we're going to be focusing on user goal level use cases and subfunction. So when you've learned about use cases, there's summary level, user goal, and subfunction. We've used summary level for the most part to support requirements engineering and solution design. You can certainly go to the user goal level at any point, but when we get into design, we're pretty much focused on user goal level, use cases, and subfunction level. So user goal levels focus on specific goal of the actor, where the actor could be a human or a machine. And they want to achieve by interacting with the system particular objectives of the use case. When we get to the subfunction level use cases in design, this is the lowest level use case, describing smaller specific tasks or steps that are part of the user goal use case. Subfunction use cases are often reusable components that support higher level use cases as we're working through our design and implementation within the project. Now, in starting use cases, the very first thing that you need to understand are the actors. And in this case, we've cloned the actors in this project from release 1 to release 2, and then for design. And then we have versioned these so that we could have a design conversation around authenticated customers versus unauthenticated customers. We've also brought in marketing and sales, and of course, the data science group. Not necessarily scientists themselves. They could be data analysts, data engineers, and so on. We just put them under the actor called data science. So the first thing you need to understand and bring in for your use cases are your actors. And again, these actors can be human or they can be machines. The next thing that we need to have when we're starting our use cases is an understanding of the systems. Let's just drill into this one here. So I have changed the shape here from the normal round and quarter rectangle into an ellipse. So we have systems here around Arco platforms. This is the e-commerce website, and other platforms that are underneath the company Arco. And these could be your CRM systems and other, but blanket coverage here for our co-platforms. The next set of systems is the data science platforms, and we'll get into that in a moment. So as we're building our use cases out and bringing in our actors, we want to make sure that we're generalizing our actors. So here is the original element representing an authenticated customer coming from our use case actor catalog for release 2. So you generalize your elements so that you're able to have a specific conversation around that specific element, in this case, actor. I recommend that you never use an instance object, right? So this is an object instance of this particular actor. So when you're bringing in an actor, let me just go here. We're going to find it in the catalog. Here we go. And this is under the design use cases where we have versioned these. So if I bring in an authenticated element, this case customer, I have the ability to use a link, which is right here, or use generalization, which is right here, or bring in an instance. I would recommend that you never bring in an instance. It's best to bring in generalization so that you have inheritance of the tag values and other properties of the original element. Next, we're going to get into class diagrams. And class diagrams are useful to model static structure of our ML AI components, such as data structures, models, and pipelines. So the solution architect handed this one over to us. We cloned it, we versioned it, and we're going to use it to understand what impacts out of the building blocks that represent the design from a DSA perspective. Again, DSA stands for Data Science Architecture, or sometimes we say DSAG, DSAG, Data Science Architecture Group. I'm just going to keep saying DSA. So the solution architect normally does not work with lower level systems, building blocks, such as when we get into the frameworks, the platforms, and the tooling that represents the DSA architecture. So under these building blocks here, there are a lot of systems that are participating within the architecture. And so when we go to our platforms, frameworks, and tooling block diagram, a lot of these systems here have been stereotyped or they've been tagged out representing whether they're platforms, frameworks, or specific tooling that's used for data science. I like to use Kanbans to represent the phases of where each element is in its delivery lifecycle. In previous episodes, let's just take the Kafka data bus architecture here. We've used phase to represent the release. And as I stated in those previous sections, I like to use tag values. So in this particular case, we have a release for tag value, and we're calling out release 2 and tagging the elements as we're going through design iterations to represent what release they're in. So with Kanbans, you can see here that if I go to elements in this, we have, this is in the test review phase, the test review phase. And as elements are done in design and I can move them into another phase or even back, remember it's iterative, you would see that this automatically changes the phase to done. In this case, this is not done. I'm going to bring it, drag and drop it back into test review. And this again could go back into the queue or in progress, most likely go back into in progress as you're collaborating on these elements, discussing these things with your peers, working through delivery. They could cycle back and forth within your Kanban, but remain consistent within a specific release. Also from this channel, when you're doing use cases, you're able to auto-generate your models from using scenarios from each use case. So you're able to generate activity diagrams, which are critical within the architecture, the design for visualizing dynamic workflows of your AI processes. And you can embed other models that are linked to activities. In other words, you can drill down in other models to represent specific actions or activities within your design architecture. And as you've learned in the channel, you can take any element and you can drill down further. In this case, we're going into a predict decision tree class diagram that represents the data science approach using various tooling. And you can even drill down into the code relevant to, this is the Python, relevant to this decision tree implementation. Now, our data science group doesn't always use Sparks to model their class elements. They use Plant UML, which is going to be covered in this channel. And for the code that they are implementing, in this case, Python, they're using their own IDE. And in this case, this was developed using Visual Code, but you could use any IDE technology that you want, or you can even code in Sparks and then write back to the code repository, which in this case is Git, for your implementation. For example, in this case that you see here, this class diagram, they used a pattern. They used a pattern to actually design the real working model. And the real working model is where they do their design and their documentation to the stakeholders to understand how the model is going to work from a component architecture perspective or a code perspective. So when you're collaborating with your other engineers, you can see here that we're building customer from the customer database. This could be the customer product database or the entire profile for the customer, such as customer to product, affinity profile, or CPAP, as you might have heard me call in the past. They're building it from there. So when you're working on your code from this perspective, you could come in when you're collaborating and creating your data set. You could say, hey, we want to bring in other data to represent our decision-making process, supporting personalization and offer recommendations. Next, we're going to talk about sequence diagrams. And again, it's best or most productive to start your sequence diagrams from your scenarios. So you're able to come in here and generate sequence diagrams based on the context that you brought in. And again, you've learned about scenario building in this channel. So what we're doing here is we're building out sequence diagrams to represent time or illustrate interactions over time, especially for real-time machine learning AI or APIs. Next, we're going to talk about component and deployment diagrams. And with these, you can show modular components like data storage, processing modules, model servers that you're using, and APIs and microservices. So in this particular case, we cloned the data science architecture's platforms, frameworks, and tools so that we could use it to build out our components and other elements for deployment. So let's take an example here. And we've shown you this in this channel. I'll try to include a link. Let's take Snowflake. And right now, this is a class element, right? There's no intelligence yet in there, but we'll add that in later. We're going to go to the Design tab. We're focused on Snowflake. We're going to go to Element Panel. We're going to go to Manage, Change Type. We're going to change the type to Component. And there you go. Now, this is a component element. And what we can do is carry the intelligence, including all of the tag values. It's inherited and brought over here in order to support design from a component and deployment diagram perspective. So you could certainly right-click on this and access other things from quick access menu, or to change the type again, you could go to change type. And for a deployment view, we're going to change this to a node. So change it to a node. And now it is a node that can be used in a deployment architecture. You could create both a component and a node simply by creating new versions of the same element and carry forward all the intelligence relevant to those elements in your design. Now, as we're picking our components and working through our design, we're able to bring our component architecture together in a component view and or a deployment view for our design. Next, we're going to talk about state machines. And this state diagram here was auto-generated from our scenarios. Now, we do this in high-level design, create state machines, and this is a very simple one. Doesn't have a lot of behavior in it. But what we normally do is we'll pick any element here. We're going to pick CMS Ghost. So they're using a headless technology here, and we want to represent state from this API, this component perspective, so that you can come in here and you can create state machines from this element. I'm not going to do this. I'll do this in a separate video because this video is already getting longer than I wanted it to be, but you're able to do quite a bit from Spark's Enterprise Architect without any other modeling tools. All right, we're going to start to wrap up here, and I wanted to close with some pro tips. So keep your diagrams simple. Avoid overloading these diagrams with excessive details. Focus on components and flows. You may have more complex models that you can clone and generalize to help represent specific occurrences. Next is use standard notation. Stick with UML2 as you're going through for consistency, but adapt notation for machine learning specific data sets as you're going through and models you're producing. The next one is iterate and refine. That's a powerful thing in Sparks, is that you're able to collaborate, move back and forth between specific phases and conversations that you're having. So collaborate and stakeholders is mission critical to share with those data elements as you're working through design. And you may be working with multiple team members on this, and each one of them may be working on different views of the architecture in real time. Plant UML is heavily used in the design and machine learning architecture area, but you choose the tools that are most productive and fit your company's budget and outlook. I'm just stating that Sparks is a better return on investment for generating models and documentation. So that's going to conclude this episode. Thanks so very much for watching this far. Please like and subscribe if you're not already. Most importantly, you can leave comments down below, questions and concerns, and we'll try to cover those questions and concerns in future videos. So until that next episode, happy modeling.